Hello, everyone. Just back here. Got a more prominent threat with this upcoming storm than the last one, so that's why I kind of fizzled out on the last storm. This one's a little more interesting. This is a setup that I've seen quite a few times, especially as you get towards the end of winter. This is the setup that I constantly see. Is when you have. This is what we have. This is Thursday evening, the GFS run from this earlier last night. You have all this southern stream energy that's out ahead of a trough from the northern jet stream, and what this short wave does is going to depict what the southern stream energy does, where it goes, and how the storm forms and where the storm goes and such. So you might look at this flow and say, oh, well, it looks like the southern stream energy is going to go north. But something to really think about here is that, yes, there's a dip in the jet stream, but it's not like a major dip. So when there's a strong dip in the jet stream and you have a trough that's digging all the way down into the south, that's called the meridional flow, where it's not, so flat, so to say. So yes, there is a little bit of a dip, but it's not that extreme. This is what we call a zonal flow. So when you have zonal flow behind a trough, you expect that the short wave will weaken and flatten out as it continues to progress to the east-northeast. And what that does is, as this short wave flattens out, it suppresses the southern stream energy further south. So you get a more progressive system as opposed to a nor'easter that comes up the coast. So a couple things to keep in mind here is the track of this short wave behind the southern stream energy, how quickly it moves and how quickly it flattens out will determine how far north the storm comes. But the storm itself is going to be more progressive as opposed to a nor'easter. There is still the potential to get a lot of snow out of it, and I'll explain why, but let me just first show you what happens. So this is Thursday evening. This is the southern stream energy. Your storm is somewhere across the Ohio Valley, and precipitation is extending to the east. So we're going to watch this energy, and we're going to watch the shortwave back here move to the north and east. So watch it flatten out. So southern stream energy now at Friday morning is further east. It didn't go north because the flow is zonal, so it could only go slightly to the north and east. So the flow was pushing it to the east, and now our trough is further north, and there's not much of a dip, so it's starting to flatten out. And there it goes. It flattens out, and it weakens. And so the southern stream energy is allowed to get a little bit far north, but not much. So as you can see, just to show it again, right now it's more north-south oriented, but then it flattens out and becomes east-west oriented, and it keeps the southern stream energy suppressed to the south as long as the southern stream energy doesn't get too far out ahead of it. If that happens, or if this doesn't flatten out, then the storm comes further north. Okay, so that is kind of the idea. And in my experience, I remember when I was in high school, there was a number of scenarios like this where there was the northern trough and southern stream energy, and usually the northern shortwave wins out and suppresses it further south. Now, the models have actually been fairly consistent with the track. They've been oscillating north-south by about maybe 200 miles from run to run. So I don't really see much of a trend going on. But I just, in my experience, I've noticed that these systems tend to go towards DC and Philly, and not as far north. But it's not always the case. So again, it's going to be dependent on how quickly this shortwave flattens out and how zonal the flow is. The more zonal it is and the quicker it flattens out, the further south this storm will be. If the energy gets out ahead of the trough, or this is just further back to the west and doesn't flatten out, then you get a storm that comes further north. Okay, and then the other thing to look at is temperature and wind. So there's the low off the coast, but I want to go back a minute. So first off, I want you to notice that we do have cold air in place, and let's go to Friday morning and Friday afternoon. We have cold air in place, but the low is going to bring in some warm air, depending on how close to the coast it gets. There is going to be an issue with sleet with this storm. as you get close to the rain and snow line. So wherever the rain and snow line sets up to the north of that, you're going to get some sleet mixing in with your snow. And I'll go over that as well. What you want to look at here is the wind flow. So when the low is back here, you have precipitation out ahead of it, and behind it, you have the wind barbs are pointing to the Gulf of Mexico and the Atlantic Ocean. So even though this is not a strong storm by any stretch of the imagination, I mean, 10, 11 millibars is not strong at all. You still have a lot of moisture pluming in and going over this temperature gradient, which is where you're going to get all the precipitation on the to the north side of this low. There's a boundary here that it's riding along. So because of the plume of moisture coming in, despite this storm not being that strong, you are still able to get heavy precipitation on the northern end of this. Okay, so I just wanted to make that abundantly clear. And then the other thing, I did want to show the surface map. I'm trying to think if there's anything else I wanted to show here. I don't think so. So now we're going to come to the surface map. Okay, so this is the GFS again. This is on Thursday evening. You can already see your snow and ice moving in back across Ohio and Pennsylvania. There's some freezing rain and sleet in there. I don't think freezing rain is going to be too much of a threat. I think it's more so the sleet. I could be wrong though, but I'll show you why. Then Friday night it moves into Pennsylvania and going eastward again. And let me just check something. I want to check a sounding here. Yeah, no, that looks more like sleet to me. Well, could be. It's so what you want to look for here is this is the 0 degrees Celsius line or 32 degrees Fahrenheit. So if the temperature line is going over that, when the snow crystals are still in the atmosphere, then that means that the temperatures are above freezing and the snow crystals are going to melt. So model has this as freezing rain probably because the warming is occurring closer to the surface. So what happens is it melts into rain, and then when it hits the surface is below freezing, so the rain freezes. If this warming took place higher up, maybe around 700 millibars, and then came back down as such as it is going to be doing in some places, then it'll be sleet. So that's what happens. Sorry. So let's just go ahead. Sorry. All right, so now you have your snow late Friday night, and then Friday morning, you're going to get the heaviest snow and sleet right above the rain and snow line. That's where the moisture is pluming the most. So the further north you go, the less snow you're going to get. And of course, we have problems with sleet now. So it's going to depend on the temperature profile, but there does seem to be a decent chance of heavy snow, sleet, and maybe a little freezing rain near the rain and snow line. Just to the north of that line, you'll have problems with sleet and freezing rain, as well as heavy snow even further north than that, and even in those same areas as well. So this wouldn't be a blockbuster storm. Progressive systems typically don't produce more than a foot of snow in the areas that get the heaviest snow. But it would still be a very disruptive system for the area. So now, that in mind, I made a map. Here it is. This is the because there's going to be different precipitation types, I called it the threat for winter storm because at the southern end towards the rain and snow line, you are going to get freezing rain and sleet. More likely sleet, I think. So I think there's a chance for the trend to go south, based on my experience with these types of systems. So I have my snow threat a little further south than what the models have right now. And I also have a little further north, too, just in case it trends back north instead of south. But I have a feeling it's going to be either consistent with what it is now or come a little further south. So the threat would include Boston, Worcester, parts of Maine, New Hampshire, Vermont, most of the state of New York, including New York City, Long Island, Lower Hudson Valley, Pittsburgh, and I can't remember the other names here, Harrisburg. Philly would be on the cusp of this threat. Um, not entirely sure yet about Philly. Trenton would be on the cusp of this threat as well. You would be more likely to get freezing precipitation with the current track, but if it tracks further south, then you would be in the threat for snow. Okay, so again, the main things to watch here. I'll review them quickly. One, how fast does that shortwave trough behind the main system move to the east and flatten out so it can suppress itself? How fast does that happen? Um, how good is the moisture advection for the storm? The wind barbs are pointing towards the Gulf of Mexico, so you get all that moisture, you get more snow. And where's the rain and snow line going to set up? Because to the north of that rain and snow line, that's where you're going to get the heaviest snow and problems with sleet and freezing rain. And what will the trend be? So those are the things to kind of look out for here with this system. I mainly forecast for the Northeast, so that'll be my focus. If any updates happen, I will post again probably on Tuesday, but if anything happens before then, I'll post on tomorrow. All right, thank you for watching.